In question number 8, we should verify these two expression, and here matrix A is given. Now we'll prove for first one. Adjoint A, inverse of adjoint A is equal to adjoint of A inverse. So now first we'll find adjoint A. For that we should find minor and cofactors. So let's start with minors. So first row, first column means 15 minus 1, that is 14. Then first row, second column means minus 10 minus 1, that is minus 11. Then first row, third column means minus 2 minus 3, that is minus 5. Second row, first column means minus 10 minus 1 minus 11. Second row, second column means 5 minus 1, that is 4. Then third row, first column means minus 2 minus 3, that is minus 5. Third row, second column means 1 and plus 2, that is 3. And third row, third column means 3 minus 4, that is minus 1. So accordingly, cofactors will come here. So we can write same, sign change, same, sign change, that is 11, then same, sign change. I didn't find 2, 3 here, so 2, 3 should find. Second row, third column, second row and third column means 1 plus 2, that is 3. So 3 will come, so minus 3. Then same, then sign change, last one is same. So adjoint A we can write as first 3 entries, first column, next 3 entries, next column, last 3 entries, last column. Okay, this is adjoint A. Now we should find inverse of adjoint A, isn't it? So we will suppose this matrix as B. That means B inverse we can find. Okay, so now I will write somewhere B matrix because this is going to be used later. Now after finding adjoint A, we should find A inverse. So for that, determinant A we should find by using cofactors we can find, that is by using this formula. So A11 means these elements and capital A11 means these elements will come here. So what will be determinant A here? 1 into 14 minus 2 into 11, that is minus 22 will come. Then 1 into minus 5 means minus 5. So 14 minus 27 will give minus 13, which is not equal to 0. So A inverse exists, and that A inverse will be 1 by determinant A adjoint A. So determinant A we got as minus 13 and adjoint A means this matrix. Okay, now A inverse we got. Okay, adjoint of this we should find because RHS of our expression is adjoint of A inverse. That means we should find minor and cofactor of this matrix, isn't it? So A inverse also I will write somewhere. We need this matrix also later. Now for finding minor and cofactor of this, first we should write matrix in this form where this minus 1 by 13 we should multiply with each of the element. So we'll get minus 14 by 13 minus 11 by 13 and 5 by 13 will come. Similarly, minus 11 by 13, 5 by 13, minus 4 by 13, 3 by 13, and here 3 by 13, 1 by 13. Okay, so this is A inverse. Now we'll find minors and cofactors of A inverse. So M11, M12, M13, M21, 22, 23, 31, 32, 33. Now first row for this matrix, first row, first column delete. So minus 4, minus 9, minus 13 by 169, that will give minus 1 by 13. Then first row, second column means minus 11, minus 15, minus 26 by 169, that will be minus 2 by 13. So I will write here minus 2 by 13. Then next is first row, third column means minus 33 plus 20, that is minus 3 by 13, 13 by 169, so minus 1 by 13 we can write. Then second row, first column means minus 11 plus 15, minus second row, first column will give minus 11 plus 15, minus 15, so it will give minus 26 by 169, so minus 2 by 13. Then second row, second column will be minus 14 and minus 25, that will be minus 69, minus 65, minus 14, minus 25 means minus 39 by 169, so it will be minus 3 by 13. Now second row, third column means minus 42 plus 55, that is 13 by 169, which is give 1 by 13. Then third row, first column means minus 33 plus 20, minus 13 by 169, that is minus 1 by 13. Then third row and second column will be minus 42 plus 55, that is 13 by 169, so 1 by 13 will come. Lastly, third row, third column means 56 and plus 121, that will give 65 by 169, so minus 5 by 13. Okay, so final answer of cofactors will be here same sign change, same sign change, same sign change, same sign change, same. So adjoint of A inverse will be first 3 entries, first column, next 3 entries, next column, then last 3 entries, last column. Okay, if we take minus or only 1 by 13 out, will be getting, I am writing here because we need this afterwards also, 1 by 13. We are taking 1 by 13 common from each of the element. So minus 1, 2, minus 1, 2, minus 3, minus 1, minus 1, minus 1, minus 5. Okay. Now we got our RHS. To find LHS, we should find B inverse, isn't it? B matrix we got already. So to find B inverse, first we'll find minors of B. So B metric is this metric. So I'll write here. So inverse of this B, isn't it? And this B is nothing but adjoint A. So we'll find minor and cofactor for this. So M11, M12, M13, M21, M22, M23, 31, 32, 33. So first row, first column means minus 4 plus minus 9, that is minus 13. Then first row, second column means minus 11, minus 15, that is minus 26. First row, third column, minus 33 plus 20 means minus 13, isn't it? Then second row, first column means minus 11 and minus 15, that is minus 26. Second row, second column, minus 14, minus 25, that is minus 39. Then second row, third column, minus 42 plus 55, that will give plus 13. Then third row, first column will be minus 33 plus 20 means minus 13. And third row, second column means minus 42 plus 55, that is plus 13. And third row, third column means 56 minus 121, that is minus 65, isn't it? Now correspondingly cofactors will be first one will be same, second sign change, third same, sign change, same, sign change, same, sign change and same. Okay. Now determinant of B. See, since this is B matrix, so B, all cofactors will be in B form. Now determinant of B. So determinant of B will be B11 using cofactor, isn't it? Plus B12 capital B12, B13 capital B13. So this will be all small b11, b12, b13 and adjoint of B, I didn't write, adjoint of B metric will be minus 13, 26 minus 13, then 26 minus 39 minus 13, then minus 13 minus 13, 65, minus 65. Okay. So this will make all capital B11, B12, B13. This I wrote here. Okay. Now 1 into minus 13, 14 into minus 13, B11 is 14, then B12 means 11, this metric, okay. B11, all B11, B12 and B13 element will come from B metric. Then B12 means 26 plus B13 means minus 5 and here this is minus 13. So it will be minus 182. This will be 286 and minus plus 65. So if you add these, you will get 169, which is not equal to 0. So B inverse exists and B inverse will be equal to, I will write here, B inverse is equal to 1 by determinant B adjoint B, isn't it? So 1 by determinant B means 169 and adjoint B means this metric. So minus 13, 26 minus 13, minus 26 or plus 26, minus 39, minus 13, then minus 13, minus 13 and minus 65. Now if we take join B. Now if we take 13 common from the matrix, so here minus 1, 2, minus 1, here 2, minus 3, minus 1, minus 1, minus 1, minus 5, and this will give 1 by 13, minus 1, 2, minus 1, 2, minus 3, minus 1, minus 5. Okay, B inverse means what? B we have supposed as adjoint A, so adjoint A inverse. So this is LHS of our this expression, and here this one is RHS of adjoint of A inverse, RHS of expression. So verified, isn't it? Now for the second part, we should prove A inverse of A inverse equals to A. Now if we suppose A inverse as C, that means we should prove C inverse equals to A. Now A inverse we already got here, that is nothing but C. So to find C inverse, we should find adjoint of C. So this is what? Adjoint C. And determinant C also. So the only thing is left here to find determinant C. So how will we find determinant C? So what we will do here, we will write this A inverse. Let C is equal to A inverse. This already we got as minus 1 by 13, 14, 11, minus 5. Okay. So from the previous step we are getting, so we can write, we can name that part as 1 and we can write from 1, isn't it? Now adjoint C already we got here, adjoint C, that is adjoint of A inverse. Okay, now determinant C we should find here. So to find determinant C, that means C11, small c11, using cofactors we can find. Okay, small c and capital C. So for that, this will be element and this cofactor element. So minus 14 by 13 into minus 1 by 13. C12 means minus 11 by 13 into 2 by 13. C13 means minus 5 by 13 and this is minus 1 by 13. So we will get 14. This will be plus 5 by 13. 14 by 169 minus 22 by 169 and minus 5 by 169, which will give minus 13 by 169, which is minus 1 by 13, which is not equal to 0. So determinant C inverse exists. Okay, and what will be that C inverse? So C, determinant C we got as minus 1 by 13. So C inverse will be minus 1 by 13. C inverse, which is A inverse of inverse, isn't it? C is A inverse, which is 1 by determinant C adjoint C. So 1 by determinant C is what? Minus 1 by 13. And adjoint C is this matrix 1 by 13, minus 1, 2, minus 1, 2, minus 3, minus 1, and minus 5, minus 1, this matrix, minus 1, minus 1, minus 5. Isn't it? This 13 will go, so you will be left with minus 1 outside. that we can multiply with each of the element. So we will get 1 minus 2 1 minus 2 3 1 1 1 5. So this is what? This is our A matrix, isn't it? You can check, you can verify. So this is A matrix. So here we verified second part also.